Okay, so this time let's talk about table objects, but get a little bit more into detail here, and we'll continue building up the demo table, which is really just going to be an exact clone of the one that is included with the project. But sometimes it helps to just kind of step things back and redo it all from scratch to get a good idea of what's happening. So what we're going to do is make a bumper, and like our walls, this is just going to be a custom class of table objects. So let's first give it a name so we can identify it in the property list. So there we go. We've got bumper, and in my texture, or the textures that I've already imported here, I've got one named bumper1. And actually, let's go ahead and take a look at that real fast. It's a relatively simple animation, so you can see here's the first frame of it, and then what will happen is when you bump into it, obviously it does this, and then goes back down to its original state again. And a lot of my animations do that. They kind of ascend up to, kind of their one frame and then go right back down again to kind of loop back to the original look. So after you've got that in there, we are about 2 steps into setting this up. Actually, really just about 1 step. We want to go over here to our custom class, and like the walls, that's going to be TableObject. Then cut back over here, and this is the one that I sometimes forget to do, which is actually give it a physics body, or occasionally too, I'll give it a physics body and I'll forget to toggle off these options over here. And if they're left on, dynamic allows rotation and affected by gravity. Mostly affected by gravity is the one that accounts for this. The object is just going to go right back down. You're probably never going to see it because by the time the scene fully loads up, it's already disappeared down the drain or wherever it's escaped off to. Now you could have a table object that is dynamic and allows rotation, but as long as you've got affected by gravity off, it would stay here, but it's part of the physics simulation. So the ball colliding into this is actually going to make an impact on it, and it's going to move around somewhere. But you can play that to your advantage. It could be an element on the table that's meant to do that, right? Or you could turn off dynamic and just leave allows rotation on. And in my the demo that I submitted to Apple, that's what this badge is doing over here. See this little guy? It's kind of spinning around. And I actually do have an SK action that is constantly rotating it, but it is also set to allow rotation. So if the ball bumps up against it, it's going to give it a little bit more of a rotation, and it'll kind of seem like the ball made it spin even more. So there's lots of cool things that you can do like that. But let's continue on here. So we've let's make sure that is set to off, and let me put this a little bit more in the middle of the screen. There we go. Okay, so we've got bumper, and if you want to have multiple bumpers, which you probably do, all you have to do is simply duplicate one of them, and there you go, grab that guy. So the properties that we feed into this bumper are going to be for each one of these, all right, because they're all named the same thing. There's no conflict with them having the same name. Obviously makes things a little bit easier. And what we'll do now is head over here to the tables.plist, and you can see that even though I copied all of my settings from this one particular table over here, including all the subdictionaries, I've gone ahead and just wiped out the properties that we already had in bumper, so we can kind of pretend like we're setting this up from scratch. So let's you'd start by unfolding these and or creating a new dictionary altogether. So let's pretend like we're making a new one. We'll just put in here bumper. We're going to set that to dictionary, and obviously that matches the name of the table object I've got in the scene. And then I can just start adding in properties over here. So one of the first ones we might want to do is just put in here sound or sounds. Both of them actually are in the code. I account for a lot of pluralization. Not all the time, so again, always check with the official documentation for the exact property name, but in this case you can go with sounds or sound, and I'm going to set this to be an array so that it'll pick out a random sound from inside of here. So I'm going to unfold this, and we'll put in here bumper hit.caf, and that's the name of a sound file that is included with the project. And actually there's 3 of them in here, bumper hit 2 and bumper hit 3. So again, it's going to randomly pull one of these sounds and play it, so you get a little bit of a variety in here. Here's an option that I'm going to leave off, but and by leaving it off, it's by default off anyway. So I could just as easily delete this property altogether, and it would do the same thing. But I'm going to just leave it in here for reference. But what you could do is set a Boolean value, which is going to be yes or no, to play the main ball roll sounds after the ball has contacted this bumper. And the main ball roll sounds are defined over here in your sounds dictionary. So you can see, here we go, ball roll. And again, this can be an array, so it's going to pick out one at random. And that way you can, if you wanted to, play a ball roll sound afterwards. So here's a fun one. I'm going to include this in here, enhance impact. And this is going to be a number type value. And I'm going to set this to be 2. Now this is very similar to the restitution property. And let me go select one of my bumpers here. And you can see over here that if we scroll down, any one of your physics-based objects has a restitution, which is essentially the bounciness of it. And I just found that the restitution at its max range, which is 1, wasn't always bouncy enough. Okay, so that's why I included in the enhance impact option, which can really bounce the ball off a kind of exponential value. So I would say start at 2 and then go from there and see what it does. And if you add a little bit too much, all bets are off. I think it just fly right off the table. Now the next one, let's go ahead and put in here a body type. Put in body type. There's going to be a string type value, and we're going to put in here circle. Okay. Now we've already given our bumper a physics body that is set to circle, right? I mean, we all remember that from just a moment ago. There's the bounding circle around it, but you'll notice that this is not exactly perfect. Okay, I've got a little bit of a drop shadow that I included in here, which is confusing Sprite Kit a little bit about where it should kind of create. Well, actually, in this case, since it's a circle, it's just looking at the total size of the image and just making a circle around it. If, though, I set this to alpha mask, you'll notice a similar issue happening. Okay, so I put an alpha mask over here, and a little bit of that shadow is being included as part of the body. That's not that big of a deal, but I'm going to set this back to being a circle again, which really actually just kind of doesn't matter since I'm going to override that with the property over here. But I do kind of want to demonstrate what this does. So body type is set to circle, and then what I'm going to do is I'm going to set the radius divider. So put in here radius divider. All right, and this is going to do a little bit of math on how to define that circular shape. Now 2, if I had that in there, is going to do exactly what's going on right now. It's basically going to define, it's going to look at the width of the image and divide that by half to create the radius, right? The radius is what, half the width of a circle. Okay, so if you had this at a higher number, like 3, that's actually going to make the body of the bumper or circular body of the bumper a little bit smaller. Now on top of that, what we can do is we can also set a body offset. So let's go over here, set body offset. And even though this looks like a number that we're putting in here, it's going to be set as a string. And you'll notice that if you did try to leave this at number and then include in the required stuff, like you have to put this in squiggly brackets. So let me just kind of put it in here and I'll show you what happens. So this is how it would normally look, right? But if I hit return on that, it's just going to go back to being 0 because it only allows numbers inside of there. So you can't really make that mistakes. So set this back to string, and then I'm just going to paste in what I had. So what's happening here is this is basically going to make under the hood, it's going to make a CG point value from this string. And to do that, the required format is opening squiggly bracket, ending with a closing squiggly bracket, and then your 2 numbers for the X and Y locations separated by a comma. And you can actually include spaces in here if you kind of want to pretty it up a little bit. Those are ignored. So what I'm doing here is I'm offsetting the body by 0 on the X-axis. So horizontally, the physics body is not going to get shifted around, but I'm going to shift it down by 10 points on the Y-axis. Okay, so let me go ahead and just build this in so you can see what that looks like. Okay, so I've got this zoomed in a little bit, and you can see that circular body is now obviously a lot smaller than the bumper artwork, and it's been shifted down below the center point of it. So if you did something like this, you would, I'm not even going to try to do this on screen, but if the ball did go over here, depending on the bumper's Z position that we set it up at in the scene editor, the ball might appear above the bumper, or it might appear below it, right? Now, if you wanted, you can set a property named dynamic depth, which would make it so that if the app sees that the ball is above the bumper, or whatever the object is, it's going to make this be visually higher than the ball by just one level, okay? But then if the ball descends lower than here, it's going to actually take this same object and move it behind the ball. So the ball is always going to stay at whatever its Z position normally is, but any objects that you set with a dynamic depth equaling yes are going to kind of constantly be in flux of their position. Now, you're not going to notice it, hopefully, unless you had some other objects in here with similar depths around it that would be revealing that it's kind of going back and forth. But in most cases, that's just not going to be the case. So let's go ahead and just play around with that. It's a dynamic depth. And we're going to set that to a Boolean value. And anytime you see in the documentation for the kit a reference to either a yes or no, that's going to be a Boolean value. It should be clear, though. I think I've noted it most places. And now let's go. And by the way, I don't think that this is a great property to include with everything. I mean, in most cases, you just don't need to do that, because we'll take, for example, this wall over here. The ball is really never going to, it can't occupy the same physical space, so it can't kind of overlap this anyway, right? But in a case where we've adjusted the physics body, made it smaller than the object, then you might want to do it. Okay, so moving on. This is one I usually put in for any sort of a table object. Reset on ball loss, and I'm going to make that equal to 0. So what that's going to do is it's going to make the table object go back to its original position if it did get shifted somehow at runtime, which is another property you can set. But more importantly, it's going to reset the look of both the initial texture, so any animation that had played, it's going to go back to the original texture. And this would also take away any goals that the table object had contributed to. Okay, now a lot of goals, ones that simply activate lights, things like that, they don't really matter. But if this was a more important one, for example, you had to hit the bumper 10 times to activate safety bumper or something like that, well, it's going to take away all kind of the credit that you had accrued toward that goal and wipe it out. All right, so let's see. We need to go ahead and get in the animations. These I'll copy in because we saw this with the light video. So Atlas, that's going to be bumper, and that's where I've got all those animations stored. The collision animation, those are all listed inside of here. And actually, you can see what I did was a little bit different than what I described. When you collide with the bumper, it's going to kind of immediately go up to its most lit up version, and then it is kind of jumping around a little bit. I guess I put in some sort of I don't know, whatever it is, I thought it looked good, but feel free to rearrange those. I don't know, it went 8, 9, 2. That's kind of odd. So anyway, here's another one. Score, anything you want to give a score to. I mean, any object that you want to contribute toward the player's score, put score in there, and just start setting your kind of abstract values for how important that particular object's collision is. And let's see, we've also got over here, I think I left the default frame rates at 30 for the bumper and the demo of the kit, but you can set the collision FPS, so that would be collision FPS, and this is going to be a number type. So if you wanted to speed up or slow down that animation, 10 would slow it down, whereas 30 is going to be the default. You could even bump it up to 60 if you wanted to. And since we've got a little bit of time left, let's go and put in here a goal, because this is an important aspect of the kit. I'm going to put in here adds to goal, and I did account for some pluralization here, so if you put an add to goal, it's also going to detect it. And for the string, or for the goal that we're going to add to, let's make this called use safety bumper. Now all these goal names are ones that we're choosing on our own, okay? So don't think that you're locked into any sort of suggestions that I've put in here. So let's go and unfold the goals and create a new one over here. So I named that one use safety bumper. And I'm going to make this, I just copied it from the other one, so it's got some values already in here. So this one is achieved at, let's make it something like 5. So every time you hit a bumper 5 times, it's going to activate this particular goal. All right. Now, when we do activate it, we might want to reset it. Okay, so put in here reset goal, and this is also going to be a string value or an array value of any number of goals that you want to reset after this one has been achieved, including itself. So if you want to make this particular goal back down to 0 again, just put in there reset goal and string value of use safety bumper, or you could just do this, set it as an array, and put in multiple goals to reset, and again put in itself if you want to, right? Okay, so let's activate a safety bumper. And what we'll do is put in here a new item, which is going to run when the goal has been achieved. This is going to be animate node to node. And this is one of the few properties that's going to be set up as a dictionary, other than kind of your main ones over here, but one of the few goal ones that's going to be a dictionary. And the items that you list inside of here, the keys are going to be the names of a node in the scene. So let's put in here safety bumper. And when I say node, that can be really kind of anything, because what we're adjusting here is just the position of a particular node, which all SK nodes have a position property for. So it doesn't matter if it's a light, table object, flipper, whatever it is. So safety bumper is going to be the name of it, and then we're going to move this to, and this is going to be again a string value. This is just going to be the name of anything, any node that we're going to match this position to this guy over here. So this guy is moving to this one, right? So go back over here to your demo table, and we can grab any one of our scenes, grab this, any one of our bumpers, and let's move it down. There we go. Okay, and I'm going to just put that right there. Actually, I'm going to make it a little bit lower. All right, so what I want to do is rename this to safety bumper, so it actually finds the object in there. And then I'm going to take an empty node, just drop that in, and this is going to be safety placeholder. All right, so now what would happen is when I hit the bumper 5 times, the goal is achieved, and this is going to animate up into this position right here, thus giving you a safety bumper. So now you might be wondering, well, how do we penalize people for using the safety bumper? We basically just do the opposite. Let's grab another placeholder over here and bump this guy down over here. Let's say off-screen placeholder. All right. Go back over here to our table, and let's fold this up for right now. We should make a new entry for our safety bumper, all right, because what we have in there now doesn't have one, all right, because remember we changed the name of that bumper to safety bumper. So this can do everything else that it currently does inside of here, but what we're going to want to change is adds to goal. Okay, so how about the appropriate name of don't use safety bumper, and fold that guy back up. So let's go back over here to our goals. There they are. Copy this one. Don't use safety bumper, and this one will be achieved at 1, because as soon as you basically add to the don't use safety bumper goal. It will have been achieved. And then let's also reset that goal so it goes back to 0 again. And then what we're going to do is take our animate node to node and move the safety bumper down to our off-screen placeholder. And there's actually an alternate version of this. Animate node to node doesn't provide a time that you can enter through the property list. It just moves it over 2 seconds. So if you want to move it over 1 second, you can just put in there quick animate node to node. Okay, so let's take a look at that. And I just so I don't waste too much of y'all's time, I recorded a video, and this is coming off my iPhone. So let's see, it's right toward the end that I got this to work. Okay, let's skip to right about here. I lost the ball quite a few times. And you can see I'm about to hit the bumper 5th time. There it is. And you can see that the safety bumper came up, and then I immediately ended up using it, and it went back down. So that is how that works. And by the way, I do want to point out one little minor thing. If you go back over here to your demo table, I noticed that this physics body was reversed. It's kind of an issue with let me see if I can select it. When you set a negative scale on a something that's got a physics body attached to it, so if you want to, if this happens, just go ahead and set that to 1 for the. Oh, I'm sorry. There we go. There's the scaling of it. So go ahead and reset that to 1, and this is the kind of the natural orientation of this image. It's facing that way, and then you might have to go over here and just reset your alpha mask back down to that. Of course, turn those back off again, and then reset that back to -1. But what happens is, I've seen is it just kind of reverses when you reload the file again. So most likely, if you're, to kind of avoid something like that happening, in a case like this, just bring in your original artwork facing that direction, and don't try to just flip these around like I did. Although in a case like this, it really doesn't matter, because most likely the physics body would have caught that anyway, even if it was facing this way, and just activated the light. So something to keep in mind if you spotted that like I did. Okay, on to something new in the next video.